The point estimate for population proportion P is given by the proportion of successes in a sample, and it's denoted by P hat equals to X over N. Again, we have a large population and we need estimator for population parameter, which in this case, population proportion. So we take a random sample and we find the proportion in that sample and we call it P hat, X divided by N. X is the number of successes or the number of yeses in that sample, and N is your sample size. The complement of P hat is Q hat. Q hat for the proportion of failures, which is 100% minus P hat, or 1 minus P hat. So now that we learned about the formula, we're interested in knowing the example, how to apply this formula. Example says, in a survey of 1,000 US teens, 372 said that they own smartphones. So 372 said yes. This is your X value, the number of successes. And 1,000 is your sample size. Very good. Question says, find the point estimate for population proportion of US teens who own smartphones. But how many US teens do we have? How many teenagers do we have? We have a lot of them. Can we ask each one of them? Well, it takes forever. How many days we have? How many months we have? So instead, we take a random sample of 1,000 of them and ask them, hey, do you own a smartphone? Do you own a smartphone? And we count the number of yeses, the number of successes, which in this case, we have a sample size of 1,000 US teens with 372 that said yes. Question says, find the point estimate for me. To find the point estimate, we're going to follow P hat, which is X divided by N. This is the formula for sample proportion. So 372 yeses divided by how many people in that survey? 1,000 people. We get 0.372. This is our decimal, 3 decimal places, and now we can convert it into percent, which is 37.2%. What's the meaning of that? The point estimate for population proportion of US teens who own smartphones is 37.2%. But the question is this single value representative of the whole population? As a statistician, we say that depends on the sample, how many samples we have. If I take the sample and calculate this proportion, am I going to get exactly 37.2%? If you as a statistician take a different sample, do you get the exact same percentage or they are different from each other? Because of these differences, we introduce a confidence interval, which is a range of possible values for population proportion.